Hi friends, in this video we are going to discuss the partial derivative of a function in more than one variable. Let's say first I want to discuss the function in single variable and function in two variable. Let's say here I am defining the function f of x equal to y. This is my function. So here f of x equal to y, this is my function. This y is my output. So this is my output and this x is my input. So here this x is my input and this y is my output and this f, consider this is my machine. So here this is f is my machine. Here I will give the input to my machine generate the output y. So whatever the output here I am getting in my codomain, that is completely depends on this input x. So here whatever the output, that is y I am getting with respect to this function or with respect to this machine, is completely based on this input x. So this output y is the dependent variable which depends on this x with respect to this function f. So here this is my dependent variable depend on x. Now tell me this x here, this output y is my dependent variable depends on my input x with respect to the function f. So here it depends on x with respect to function f. Now if this is the dependent variable, now this input x is my independent variable. So here I can take x anything from my domain. So here this is, so here input is independent variable which is independent variable with respect to this function or domain, from domain. Now here whatever the changes occur in y, that is completely whatever the changes occur in y, that is only depend on my independent variable x. Whatever the output here I am getting, that output is completely depend on the single independent variable x. So this is my function in single variable, that is f of x equal to y. Now here that is my function depends on the single independent variable x, that is my x is my single independent variable x. Now so at that time, so here this is my y. Now tell me f dash of x, that is f dash of x equal to dy by dx. This says rate of change in y with respect to x. So this gives the slope of the curve at point. So this gives the slope of the curve at point in single direction, that is in x direction. So here this is my, here this is equal to slope of curve at, let's say, some point at point. So here at point. Now tell me, so sometimes this is my function in single variable. Now here I will define my function. Let's say z is my function which depends on, let's say I am defining my function z equal to f of x comma y. Now in the same way, here this is my output, here this is my output z. This output z, it's completely depends on this two input x and y with respect to this function f. Whatever the output here I am getting, that output completely depends on this two variable x and y with respect to this function f. Now tell me this two x and y. Now so here f of x comma y equal to z. Now whatever the output here I am getting z, that completely depend on this two input x and y. Now f of x comma y equal to z, at that time this x comma y are working as the input and this z is my output and this is my machine. So here my output completely depends on this two variable x and y. Now these two variable x and y are my independent variable. So independent variable, and this z is my dependent variable. Here dependent variable depends on x and y with respect to function f. Now whatever the changes, when changes of z occurs, when x changes in x, changes in z, changes in y, changes in z. Therefore, the rate of change of z with respect to x, while finding the rate of change in z with respect to x at that time, treat y as the constant. Here, whenever your function depends on two independent variable x and y, these are the independent variable x and y. Whenever your function depends on the two independent variable or more than one independent variable, at that time take the partial derivative. Whenever your function depends on the single independent variable like here x, at that time take ordinary derivative. This gives the slope of the curve at some particular point. And whenever your function, let's say f of x comma y equal to z, depends on two independent variable, at that time take partial derivative. Here I will define the partial derivative. So here partial derivative of z with respect to x, here keeping y as a constant, gives dou z by dou x. So here this is the partial derivative, first order partial derivative of my z with respect to f, keeping, here I will write keeping y as constant. Now in the same way, partial derivative of z with respect to y keeping x as a constant. Now here I will write here partial derivative of y with partial derivative of z with respect to y keeping x as a constant is, so it's dou z by dou y. Here I will write x equal to constant. So here partial derivative is, while taking the partial derivative of z in x direction, at that time treat y as the constant. While taking the partial derivative of z in y direction, at that time treat x as the constant. So here while taking z in x direction, treat y constant, z in y direction, treat x constant. This is nothing but the ordinary derivative of z with respect to x, treating y as the constant. So here the definition, so here this is my first order partial derivative of z with respect to x and with respect to y. So here I will write the partial derivative in the sense of ordinary derivative. Let's say u equal to f of x comma y. So here u is my function which depends on the two independent variable x and y. I want to take the partial derivative of u with respect to x. So here the partial derivative of u with respect to x is a ordinary derivative, keeping y as a constant, So here that is, here I will take partial derivative of function u with respect to x equal to ordinary derivative. Here you know the limit, here limit delta x tends to 0, here f of x change in x plus delta x comma y minus f of x comma y divided by delta x. This is the partial derivative of my function u with respect to y, keeping y as a constant. So here similarly partial derivative of u with respect to y, that is dou u by dou y equal to limit delta y tends to 0, f of, here at that time keep x remains same, that is x as a constant, x comma y plus delta y minus f of x comma y divided by delta y. So here this is the ordinary derivative of x keeping y as a constant. This is the ordinary derivative of u keeping x as the constant. So here this is the partial derivative of x u with respect to x, and this is the partial derivative of u with respect to y. Now here this is my first order partial derivative of u with respect to x. Now here second, so this is my first order partial derivative of u with respect to x. Now I want to find the second order partial derivative of u with respect to x. The second order partial derivative of u with respect to x obtained from the first order partial derivative of u with respect to x. So here this is my first, I want to take the partial derivative of this, again this function with respect to x. So here this is my partial derivative, second order partial derivative of u with respect to x square. Now this is my second order partial derivative of u with respect to x. I want to find the third order partial derivative of u with respect to x. So this is my second order. Now I want to find the third order with the help of first order. Now so here this is dou to u by dou x square is the second order partial derivative of u with respect to x. Now I want to find the third order partial derivative of u with respect to x. Again I will take the partial derivative of this function again with respect to x. This becomes the third order partial derivative of my function u with respect to x. So second order partial derivative obtained from first order partial derivative. Third order partial derivative is obtained from second order partial derivative. In the same way, fourth order partial derivative is obtained from third order, and fifth order partial derivative is obtained from fourth order partial derivatives. Similarly, you can find third order partial derivative of second order partial derivative of u with respect to y square and third order partial derivative of u with respect to y. So here this is my first, this is my second order partial derivative, and this is my third order partial derivative with respect to x, and this is my second order partial derivative with respect to y, and this is my third order partial derivative with respect to y. Now I will solve some problem. With the help of this problem I will explain this same concept again. Now how to find the partial derivative? Here I have some function. So most of the time such kind of function they will ask in the exam. Now let's say here this question in the last year. Now we will solve some problem. So here if z equal to this, so first I will write my problem number 3. So here if z equal to this, first I will write the given information for example 3. So here given z equal to e to the power ax plus by into f of ax minus by, and we have to show here, we have to show that we have to show b times dou z by dou x plus a times dou z by dou y equal to 2 times a b z. Now here this is the given information. I have to show b times dou z by dou x plus a times dou z by dou y equal to 2 times a b z. Now here partial derivative first, here I will solve LHS. So for LHS I have to find partial derivative of z with respect to x and z with respect to y. So here if this is z, therefore partial derivative of z with respect to x keeping y as a constant. Now this is my product of two functions. So here let's say f1 into f2, product of two function, derivative of f1 as it is, derivative of f2 plus f2 as it is into derivative of f1. Let's say this is my first function, this is my second function. So here let's say e to the power, here I will treat this as my f and this is my second function. So here I will take this, let's say e to the power ax plus by as it is. So here f1 as it is, derivative of this. So here derivative of this means f dash of ax minus by into derivative of this coefficient. So the derivative of this input, that is here a plus f as it is. So second function as it is, here f of ax minus by as it is into derivative of first, that is here e to the power ax plus by into derivative of exponent, that is with respect to x. Derivative here, derivative of ax plus by with respect to x. So here a into derivative of x with respect to x is 1 and this is 0. This is simply a. So here therefore this is equal to a times this. So here this is equal to, here just observe one thing, here z equal to e to the power ax plus by into f of ax minus b. So here I will write first this, which is equal to here a. So here can I write this as z e to the power ax plus by into f of ax minus by. Here I will write this as z plus, so plus here a times e to the power ax plus by into f dash of ax minus, this is by. So here this is a times z. Here for here to here, this is my z. Here I will write z from here, and this is my a, and here a e to the power ax plus by, f dash of ax minus this is by. Now I want to find partial derivative of z with respect to y. So here partial derivative of z with respect to y keeping x as a constant. Now tell me how to find. Here again same, e to the power here ax plus by as it is derivative of second. So here derivative of second, that is f dash of ax minus by. At that time this is derivative with respect to y. So this is my minus b. So here this is my minus b plus here second so function as it is. Now this is here f of ax minus by as it is. Now this is here e to the power a, here b into e to the power ax plus this is my by here, which is equal to, just write e to the power ax plus by here f dash of ax minus by. So here this is my minus b plus, so here this is b times, so here z equal to e to the power x plus by f of x minus by. So here this is b times z. Therefore from b times dou z by dou x plus a times dou z by, therefore b times LHS, here LHS equal to b times dou z by dou x plus a times dou z by dou y, which is equal to, now tell me b times, so dou z by dou x is this. So here a z plus a times e to the power ax plus by into f dash of ax minus by plus a times dou z by dou y. Dou z by dou y, here I will write this is b times z, here bz plus, sorry, this is minus. So here this is plus, this is minus, here I will write this is minus times b e to the power ax plus by into f dash of ax minus this is by. So here just solve, this is abz plus b times, here this is ab times e to the power ax plus by times f dash of ax minus by plus this is, here this is abz minus ab times e to the power ax plus by into f dash of ax minus this is by. This is positive quantity, this is negative quantity, this is cancel, here this cancel with these things. So this is equal to abz plus abz, which is equal to 2 times abz. That's equal to right hand side. Therefore left hand side equal to right hand side. That's we have to show here. If z equal to this, then show that b times dou z by dou x plus a times dou z by dou y equal to 2 times abz. That's we have to show. This is the result. Now I will solve example 2. Question number 2. So here in question number 2, if u equal to e to the power x plus y plus z by e to the power x plus e to the power y plus e to the power z, then show that dou u by dou x plus dou u by dou y plus this is dou u by dou y plus dou u by dou z equal to 2 times u. We have to show. So here answer 2. So here this is answer for 2. Given first try the given information, u equal to e to the power x plus y plus z, and here divide by here e to the power x plus e to the power y plus e to the power z. So here this is the given information, and we have to show, here we have to show dou u by dou x plus dou u by dou y plus dou u by dou z equal to 2 times u. That's our aim. So here I will take left hand side and I will show left hand side equal to right hand side. So here my left hand side is this. So here now for left hand side I want to find dou u by dou x, first dou u by dou y and then dou u by dou z. Then I have to add all these things. So anyhow I want to get this I want to show this sum of all these three things equal to 2 times u. So here how to find dou z by dou x dou u by this is dou x. Now partial derivative of this function with respect to u. So here this is my either use here, let's say f g product of derivative product of two function or quotient of derivative of quotient of two function here, which is equal to here f derivative of g plus g derivative of f, either otherwise g derivative of f minus f derivative of g divided by here g square. So here quotient square. Now here I want to use this. Here I will write this function in terms of here product. So both are easy for me. So here if this here if u equal to this, so here I will write u equal to e to the power x plus e to the power x plus y plus z into here this is e to the power x plus e to the power y plus e to the power z to the power minus 1. So here I will take denominator in numerator by taking minus powers. Here this is, so here this is same as this. So here first as it is into derivative of second. Now here first as derivative of e to the power x plus y plus z as it is into derivative of this second. So here derivative of x to the power n equal to here derivative of x to the power n equal to n times x to the power n minus 1. So here n times x to the power n minus 1. So here derivative of e to the power x plus e to the power y plus e to the power z to the power minus 1. This is minus 1 times here e to the power x plus e to the power y plus e to the power z to the power, this is minus 2 into derivative of e to the power into derivative of this here into derivative of this. Now derivative of e to the power x plus e to the power y plus e to the power z with respect to x is e to the power x plus 0 plus 0. This is e to the power x. Now plus second as it is, that is this as it is. So here e to the power x plus e to the power y plus e to the power z to the power minus 1 as it is into derivative of this first. Now derivative of first is e to the power x plus y plus z and derivative of exponent is here this is 1. Now here I will write this same thing which is equal to here this is minus sign. So here I will write this is as here minus times e to the power x plus y plus z divided by here e to the power e to the power x as it is into yes e to the power minus times e to the power x plus y plus z into this is e to the power x times here divided by e to the power x plus e to the power y plus e to the power z to the power 2. Here I will take this as in the denominator. Now plus here this is e to the power x plus y plus z divided by here I will write this is e to the power x plus e to the power y plus e to the power z. Here now tell me which is equal to here I will take e to the power x plus y plus z common. So here I will take this is e to the power x plus y plus z, here I will take common, and from denominator also here I will take one common. Here this is equal to e to the power x plus e to the power y plus e to the power z, and here it is here minus e to the power x plus this is e to the power x plus y plus z, here this is 1. Here I will take e to the power x plus y plus z by e to the power x plus e to the power y plus e to the power z divided by here one more thing is there remains. So here this is equal to e to the power this by here which is equal to e to the power this is minus e to the power x by e to the power x plus e to the power y plus e to the power z, this is and plus 1. Now I want to find, this is my partial derivative of u with respect to x. I want to find partial derivative of u with respect to y. So here I will write the same thing as here. Now I want to find the partial derivative of u with respect to y. So here if this is my partial derivative of u with respect to x, therefore partial derivative of u with respect to y we can calculate. So here this is equal to e to the power x plus y plus z divided by e to the power x plus e to the power y plus e to the power z times. So here this is equal to minus e to the power y divided by, here this is e to the power x plus e to the power y plus e to the power z, and this is my plus 1. Similarly, partial derivative of u with respect to z, which is equal to, here e to the power x plus y plus z divided by e to the power x plus e to the power y plus e to the power z into minus e to the power z divided by e to the power x plus e to the power y plus e to the power z. This is plus 1. Now I want to add here, whenever I am taking partial derivative of u with respect to x, at that time just observe the pattern: e to the power x plus y plus z by e to the power x plus e to the power y plus e to the power z times minus e to the power x by this. So while y, this is same, minus e to the power y by this plus 1, while z minus e to the power z by this plus this. Now here I want to find, here I want to take the sum of all these things. So left hand side, here left hand side equals, here dou z, sorry, dou u by dou x plus dou u by dou y plus dou u by dou z. Now which is equal to, now tell me, dou u by dou x is, this is my dou u by dou x, e to the power x plus y plus z divided by e to the power x plus e to the power y plus e to the power z into, here this is minus e to the power x by e to the power x plus e to the power y plus e to the power z, this is plus 1, plus times this is e to the power x plus y plus z divided by e to the power x plus e to the power y plus e to the power z, this is minus e to the power y divided by e to the power x plus e to the power y plus e to the power z, this is plus 1. Now plus e to the power x plus y plus z divided by e to the power x plus e to the power y plus e to the power z times, this is minus e to the power z divided by e to the power x plus e to the power y plus e to the power z, this is plus 1. Now sum of all these things. Now here just observe one thing, here what is common, all these things, e to the power x plus y plus z by e to the power x plus e to the power y plus e to the power z is common in all. Here e to the power x plus y plus z by this is common in all. So here this is minus e to the power x by this is e to the power x plus e to the power y plus e to the power z, this is minus times e to the power y divided by e to the power x plus e to the power y plus e to the power z minus e to the power z times e to the power x plus e to the power y plus e to the power z, this is plus 3. So here plus 1 here, plus 1 here and plus 1 here, this is equal to this. Now this is equal to, now this is e to the power x plus y plus z divided by e to the power x plus y plus z. Now here if the denominator is same, so we can add numerator. So here minus e to the power x minus e to the power y minus e to the power z divided by e to the power x plus e to the power y plus e to the power z, this is plus 3. Now which is equal to, just observe, e to the power x plus y plus z by e to the power x plus e to the power y plus e to the power z is my u. So here this is u times. Now here I will take minus common from this, e to the power x plus e to the power y plus e to the power z, this is my plus 3. Now here in the denominator is e to the power x plus e to the power y plus e to the power z. So here this is cancel with this. So here which is equal to, here which is equal to u times, here this is minus 1 plus 3, which is equal to 2 times u. That's we have to show. So here this is my u, partial derivative of u with respect to x is this. Therefore e to the power x plus y plus z by this, then the partial derivative of u with respect to y, because same pattern, minus e to the power y by e to the power x plus e to the power y plus e to the power z plus 1. In the same way, partial derivative of u with respect to z according to this e to the power x plus y plus z by e power x plus e power y plus e power z times minus this plus 1. If I add all these things, I will get here, I will put e to the power x plus y plus z by e to the power x here, e to the power, sorry, this is my, here, this is e to the power x plus e to the power y plus e to the power z. So here this is my u from here given information, and here I will take common minus. So here this numerator cancel with this denominator. So here this is plus 3, this minus 1 plus 3 becomes 2 times u. That's we have to show. Now here I want to solve example number 1. So I hope please pause and line right here. So here I want to first, I will take the left hand side and I want to show my right hand side, left hand side equal to right hand side. So here I will take my left hand side. So for that purpose I want to find dou u by dou x and dou u by dou y. So here how to find dou u by dou x? Dou u by dou x equal to, so here derivative of here x to the power n, that is n times x to the power n minus 1. So here keeping y as a constant in single variable. So here derivative, that is minus 1 by 2 times here 1 minus 2xy plus y square to the power minus 1 by 2 minus 1, that is minus 3 by 2, and derivative of this, here derivative of this is here 0 minus 2x, and derivative of y square with respect to x is 0. So here this is equal to, here I will write here again, here this equal to minus 1 by 2 times 1 minus 2xy plus this is y square to the power minus 3 by 2, this is minus 2x. This minus 2 gets cancelled with this is equal to x times, here this minus cancel with this and this 2 cancel with this. So here x times 1 minus 2xy plus y square to the power minus 3 by 2. This is my dou u by dou x. Now I want to find dou u by dou y. So here keep x as a constant. While finding dou u by dou x, I am taking y as a constant. So here dou u by dou y equal to same minus 1 by 2, 1 minus 2xy plus y square to the power minus 3 by 2. Here this is 0 minus 2, the partial derivative with respect to y minus 2x plus this is 2y. So here which is equal to, here which is equal to, here I will write this is minus 1 by 2 times, here I will take this 2 common, I will later I will take. So here this is minus 2x plus 2y, this is 1 minus 2xy plus y square to the power minus 3 by 2. So here I will take this common. So here this is minus 1 by 2. So here I will take 2 common from here. This is minus x plus y. This is 1 minus 2xy plus y square to the power minus 3 by 2. So here this 2 cancel with this, which is equal to minus x plus y. This is 1 minus 2xy plus y square to the power minus 3 by 2. This is my dou u by dou y. Now here, now I will take here I want to take left hand side. So here my left hand side is here left hand side equal to here x dou u by dou x minus y dou u by dou y. I want to show right hand side. So here which is equal to x. Now tell me dou u by dou x. Here this is x times. So here here this is partial derivative of this function with respect to y is my 2y. So here this is my 2y, here this is my y. So here partial derivative of this function with respect to y. So here with respect to x. So this is minus 2y. So this is 0. Yes, this is y. Now tell me x times. So here x times dou u by dou x. So x times dou u by dou x means this is my y. Here 1 minus 2xy plus y square to the power minus 3 by 2. So minus here, this is minus y times, so here minus y times this, so here minus and one more minus here. This is my minus and this is my one more minus, and again minus x minus plus y into here into 1 minus 2xy plus y square to the power minus 3 by 2, which is equal to, just multiply this xy into 1 minus 2xy plus y square to the power minus 3 by 2 minus, here minus into minus, this is plus, so here I will multiply, this is plus times y times here minus x plus y, so here this minus with this minus is plus, so here minus x plus y, this is 1 minus 2xy plus y square to the power minus 3 by 2, which is equal to, here I will take this common, 1 minus 2xy plus y square to the power minus 3 by 2, here I will take common, this is xy and this is plus y times this is minus x plus y. Now which is equal to, here 1 minus 2xy plus y square to the power, here I will write this as minus 1 by 2 to the power, this is 3, this is my xy minus, here I will multiply this y minus xy plus this is y square. Now this cancel with this, which is equal to, here just observe u equal to 1 minus 2xy plus y square to the power minus 1 by 2, here I will take, this is u to the power 3 and this is y square, this is equal to u cube and y square, that's we have to show, this is equal to right hand side, therefore left hand side equal to right hand side, that's we have to show. Thank you.